So I'm going to solve problem number 5. And when you talk about heat, you really have to generate that heat by either burning coal or fuel like gas or natural gas, or you have to use electricity. So there has to be a way for you to compute um, how much energy you use in terms of those that are available. So you can't just buy heat, right? You have to produce it. Okay, so the first step would be to find out what is being asked in the problem. And it says here, calculate the energy produced per gram of coal. Okay, so energy is Q, and gram of coal is, so per G, per gram. Right, so you can write that down. There's only one thing, that's the energy per gram. So you calculate the heat and then you divide it by 5, right? Let's see what's the given. Here, this is the mass of the coal, and you write it out because this is going to be confusing, which one is coal, which one is gas. I mean, which one is water. And then the second thing you have is mass, oh, yikes, volume of water. Okay, and we can't use volume, but you have to write that down as the given, ml of H2O. You can multiply this by the density in order to get the mass, and the mass is 1 gram per 1 ml, and so you have 1,000 grams of H2O. And you can't assume this, you have to show it in your calculations. Okay, that's very clear. So here is V of water, and okay, this is T1 or TI TF. Okay, so initial temperature is 10 degrees centigrade, final temperature is 47 degrees centigrade. Okay, wow. All right, so your basis for this calculation is Q is equal to MC delta T. Okay, so this heat has to be the water, because that's the one you're given data on. But it's equal, so the heat that the water absorbs is equal to the heat of the coal. And that's what you're solving for here. And then after that, you have to divide the heat of the coal by the weight of the coal. So Q over mass of the coal. Okay? And this is what you're ultimately looking for. AL. Okay? How do you start? Your solution is Q is equal to MC delta T. Okay? Oh, one more thing. Because we're talking about energy here, you have to use joules, right? Okay. I guess you could, no, it has to be joules because, yeah, the calories are only used in the lab, I think. All right? Okay. So this is for the water. Okay, wait. Okay, what we really need is that one. So it's of the coal is equal to Q of the water, right? And this one is MC delta T. Okay, and the mass of the water is 1,000 grams. Okay, now here the C, use joules, 4.184 joules per gram per degree centigrade. Okay, and what is the delta T? That's rather easy, 47 minus 10 degrees centigrade. Okay? Okay. And so Q of the coal, make sure you're in degrees. 1000 times 4.184 times, okay, this is 37. Okay. Let's write that down. And we have to verify it by doing it again. So 1000 times 4.184 37. Okay, that's correct. And this is joules. Okay? And then we have to get Q coal divided by 5 grams of coal. And so you divide this by 5, right? Divide that by 5 grams. And what do we have is divide by 5. Okay, and that looks like the answer. 30, significant figures. I would say 31, right? 31,000 joules or kilojoules. Okay, and so that's the answer. And the reason because your temperature is only two significant figures, so you should really keep it within that range. Okay.